Welcome to this online video lecture. This is Dinesh, Assistant Professor in EC Department, Government College of Engineering, Tanjavur. We are in Unit 5, Application Layer. Today's topic is Domain Name System. So these are the topics we are going to cover today. Starts with Introduction to DNS and what is the use of DNS. What are the types of servers are available in DNS? That we will discuss in this video session. See, what is called domain name system? See, domain name system is a phone book of internet, and domain name system is a helper system for IP, a naming hierarchy for the internet, a directory service to translate those names into IP address. See, a protocol to perform name resolution. You can think of DNS as a phone book for the internet, helping you look up your IP address for a specific name. DNS translation creates additional overhead when connecting to websites. Internet service provider cache DNS records and host the data locally. And once the IP address of a domain name is cached, and ISP can automatically direct subsequent requests to the appropriate IP address. First of all, DNS serve as a memorable names for websites and other services on the internet. See, we are going to convert that alphabetical address into IP address. It is a translator and it is a directory to access the web server or to access the website. So through web browser software, we are going to access with the host name website address. That particular website address is going to convert into IP address. So which the DNS is going to convert that particular website address into IP address. So it will act as a translator and it communicate multiple servers and multiple client or multiple node to access and to find the destinated website. So that's the duty of DNS. So normally computer access the internet device by their IP address. DNS translates domain name into IP address and allowing you to access the internet location by its domain name. So normally what it is going to do, it's going to map name versus number. The name in the sense website address, the alphabetical address, the number, it represents the IP address, the software address. So that's a duty of DNS. So normally that particular service, if the client is going to give a request to DNS client or that name resolution or recursive server. So they have 4 types of servers available in DNS. See, it will be present within a network or within a domain. We may get our designated IP address if possible. If it is not available, we need to give a request to other servers with the help to find the particular website. This happened. So it will also updated the cache memory of local domain server will be updated the IP address. When you give the first query, it will get the response and that particular address will be stored in a cache memory. So that is very much easy to do to get that particular address. If you want to do again, if you want to access the same website, it will get the address from the cache memory itself. It will happen. And it also updated because particular website address, the whole website name will not be changed, but the website address is a dynamic one. It may be changed and the servers will be placed in the multiple location. And it also needs to integrate with all the servers. So it has to be updated. Cache memory must be updated the timely manner. This is a diagram of DNS. When the user needs to give a query to the SMTP client with the help of protocol, because it talks about electronic mail, simple mail transfer protocol client. and he needs to access the website named wonderful.com. That will give to DNS client. It's look like a domain local server, and it checks that whether the particular website IP address is available or not. If it is not available, it will forward the DNS forward that query into other DNS client. It may be a other network server. So through that, if you find that particular IP address, that will move on to your SMTP client, and that will go on to transport layer. Through the transport layer with TCP connection will generate the particular IP. Then the connection will be established. The data will be passed over. So that is the route of your DNS, or the route of accessing your website address. What is the purpose of DNS? It's very simple. Yeah, in our web browser, we type that alphabetical words, but the internet or a router or a node doesn't know the particular character address. So it needs to convert into IP address. Then only the network can understand the particular website name. For that, DNS is act as a phone book. When the user give the name, it converts into number. It's no need to memorize that numbers. It's not possible to memorize all the numbers. It may be a dynamic, it may be a static, it is not possible. So the DNS is to convert names into numbers. Then the particular IP will be put into the web browser software, the network application. Through that, we will identify the particular website address. See why DNS exists. Without DNS, we need to memorize all the IP address. It's subject to change. Whenever it needs to change, we need to update that IP address too. So that's become it's a tedious process to identify the website address. So domain names provide flexibility and human readability to the internet protocol. So domain name used in URLs and email addresses are easier for humans to remember than IP address. Google.com is very easy to understand. Other than that 122 dot like IP version 4 address or IP version 6 address, we have to memorize. So that is a huge process. In addition, network operators may want to switch IP address without having to change the domain name. That's the issue. See, we have a domain name, common website address, but that IP address may vary in a timely manner. They have a multiple servers also possible. So sometimes they will integrate, and if they will switch the IP one address to another address, the IP address can switch it up. So that time it is not easy to remember the IP or understand the IP routing also. We need to understand the network topology too and the IP routing too. Then only we can access the particular website. The network operators may want to have a multiple IP address assigned to specific domain name. It is possible. Just now we discussed about that. For example, serve content from multiple locations. So if you want to access particular data resource, that will be present in multiple server also possible. If you access one particular web page, they may have a hyperlink, they may have a video content, they may have an image. So they have a different server to load the particular page. It's also possible. So what is called DNS resource and records? There are many DNS record types that store domain name data. Here, we are given A that represent IP version 4 address, the multiple A's that present IP version 6 address. MX, it talks about the email server. They have a different database and resource to specify, to identify. This base is used to identify the particular database, web servers. NS name server and CNAME allies to another domain name, interconnecting part, and DNS record as time to live that's specified in seconds how long it can be cached by the name server. Once it expires, the name server must query for an updated record. Name resolution. See, name resolution is the first step to convert the host names. The host names are converted into IP address using a process known as resolution. So that is the thing. First thing we have to start with that first step when you want to talk about DNS. So the client use DNS to resolve a domain name into IP address. And many clients use recursive name server. So we'll talk about other types of servers, because in DNS we have 4 servers are available. 4 servers are need to suppose if you can access the particular website in the first server itself, and it may route multiple servers to access the particular website address, multiple DNS servers to identify the destinated website address. So the many clients use a recursive name servers. As I said, there are 4 DNS servers. So recursive server, and root name server, and TLD, top level domain server, and authority server. These are the 4 DNS servers are available. Using the server, we are going to identify, we are going to search the particular website address, particular query website address will be given to the user. And so if this domain is unknown to recursive server, it can start at the root. So each name server will provide the most specific answer it can. The recursive server will iterate through DNS hierarchy of zones to find an authority name server that can answer the query. So suppose the local server doesn't know the particular website address, this particular local domain server is giving a query or request to another DNS server present in another network is also possible. If the DNS server available the particular address, it will give a response. If not, it moves on to root name server. And in root name server gives a identification or gives the first step. It's like a library, and it will ask the particular book to give to the particular user, and it gives some IP address. That IP address talks about the TLD, top level domain. Then if you go for TLD will pass over the, and he gives some other IP address. That particular IP address is talks about authority IP address, and particularly the final server gives you a the particular IP, particular website, what the user want to access the website, that will be given. So each name server will provide the most specific answer it can. So the recursive server will iterate through DNS hierarchy of zones to find an authoritative name server that can answer the query. What is recursive name server? See, it is responsible for additional request. So it is like a library, and a DNS recursive server is a server designed to receive queries from client machines through applications such as web browser. So this is a client server is asking a recursive server, it's like a local server. This particular recursive server will be available in the network side, ISP, internet service provider, or a public DNS or a company. So this may have a query like www.google.com, particular address will be available. If available in the cache or a database, it checks. If not, it finds the other DNS present in other network. It routes that particular website address into other nodes. See, recursive name servers make recursive queries on behalf of DNS clients. So whatever the client needs to ask or client need to achieve, that will be take over to DNS, that recursive server. This is the first server we're going to discuss about that, and he takes responsibility. This particular server takes responsibility behalf of client. So many recursive servers only respond to query from within their own network. So sometimes it will be in the local to local. Sometimes it moves on to one network to another network is also possible. That is named as open resolvers. Will respond to query from any source. It is not about only this local and multiple networks. So we have different ISP, different internet service provider, multiple networks, integrating networks, our private networks are available. When the networks are connected, we will may find our own IP address. We will may find the own website address is possible. But some are private, some are public, some are protected. That is different. So most recursive servers also cache DNS records. So once you get the particular IP, that will be stored in a record, which is valid for length of particular time period, and it is also updating. That is very much useful for when you come for second query with the same website address, it will be given. So that's why sometimes it will see when the internet connection is lost, but you will see the website address. If you put the website address, that will be appear. That page will be appear because that page is loaded into the cache memory. That is the reason. Though the internet is disconnected, we get the web page through cache memory is possible because of that particular thing. The next server we are going to talk about is root name server. This is the first step for a translation. It acts as an index, and it serves as a reference to other or more specific locations, and it's out to root zone, and it finds that multiple websites like .com, .org, and it gives particular IP. It gives TLD IP address. So there are 13 root name servers that sit top at DNS hierarchy and hard coded into any application that uses DNS. The root name servers maintain a list of top level domain servers. As I said, it routes the TLD domain server IP address. .com, they have a particular server IP that will be given. The answers provided by the root and TLD name servers contain the name server for the next known subdomain. So suppose the client gives a query, the recursive server doesn't know about the particular query, it passes to root server, and root server passes to TLD server. The TLD server maintains the records of whether it is a .com, whether it is a properly website, or .org or .in, that things will be checked out here, and they give the particular IP that particular net node. It gives the particular IP. That IP represents the authority server. In the authority server, we find that particular IP is available or not. So if it is available, that will be given to recursive server. So the final part is the result we will get the result in authority name server. In authority name server is directly registered by the other websites too. So that authority means the server have authority to answer the queries from other name servers or from DNS clients. So once the server passed to root name, next TLD, finally it comes to authority. Authority gives the destinated what we need. The client query will be available. Client IP address will be available in authority server. The DNS records, the authority name server are maintained by a domain administrator. A set of authoritative name servers are assigned for each zone. This may be maintained by the organization itself or by external company. Many organizations will split the name servers between multiple providers for redundancy. So that's about DNS. We discussed about application layer in the previous video session. This particular topic will represent the application layer. We talked about World Wide Web. We talked about client server model, and we talked about peer-to-peer entity, how they are set up in a connection, what type of software, what type of language, what type of instructions are using for setting a connection. Like we talked about the protocol called hypertext transfer protocol and the web server. How we are accessing the web server, and web server how it will give a response through HTML format or a JavaScript that will be reserved, that will be stored, that will be viewed through your application, and multiple single web page may have a multiple server integrated applications are there. Then the World Wide Web, it talks about collection of web pages. After the web pages, we move on to hypertext transfer protocol. Then we finally come to DNS, domain name system. The domain name system is act as a translator. It's a phone book. It needs to convert that particular website address into IP address, because IP address is known by all the layers, all the node, all the networks are known by IP address. So then only we can route the packet. So once you find the IP address, it will pass to transport layer. And how to achieve that particular IP address? We can achieve the IP address through multiple DNS servers. We have a lot of DNS, 4 DNS servers we discussed. So through the DNS server, we are going to achieve our IP address. I mean the destinated IP address, what the query is achieved through the help of DNS servers. That may be local, that may have a database, that may have a cache to get that particular query or get the result of the website address. It may be available in the first step itself, the recursive server itself, or it may have a, in the request server, we needs to give a request to root name server, and the root name server gives the TL top level domain servers. Then they will sort out the list out. It's like a library. Once you go for a library, ask a person to pick a book. That's one type of server. Then it go to a specific rack. Then it will go for a specific rack, specific book. Then you like a authority, like a TLD, like a root name. Finally, you get the book and give to recursive. Then that will be stored the details. Then it give to the receiver. That will give to the user. So this is all about DNS. Thank you.